Good afternoon, class. Once again, my name is Wakwale Ahmad. I'm a lecturer at this institution. And this afternoon, we are handling the hardware. And in practice, a hardware is a tangible part of a computer. Tangible means an external part of a computer which you can see for yourself. Unlike a software, which is intangible, you can't see. But with the hardware, it's a part that external part of a computer that you can see. It is something that you can touch and feel, which means it's a physical computer itself. Is comprises of the following: 1, input devices; 2, processing devices like CPU; 3, output devices; and storage devices. The cost of hardware depends on its specification. What the company requires depends on the magnitude of the work, the magnitude of the personnel, human resources, and also depends on the cost or the financial position of the organization. So what are the benefits of investing in hardware? The benefits are many, but in the interest of time, we shall get some few. One is that it reduces cost by automating routine tasks such as record keeping, accounting, and payrolls. Number 2, it improves on customer care service or supplier relationship. Number 3, develop more effective communications within the business or with customers. Number 4, increases business efficiency and staff productivity. Number 5, expand your business over or reach new markets, e.g. through an online shop. Number 6, develop competitive advantage by implementing the right business technology. Evolution of computer system capability. Computers have developed through 5 stages, with now more developed witnessed in the 5th stage. However, most authors suggest different timelines. There is first generation computers, there is second generation computers, third, fourth, and even 5th generation computers. The first generation computers were extremely big. Their storage capacity was very low and could produce limited output. They had limited memory and processing capability. The maximum memory size was approximately 2 kilobytes. The speed was 10 kilo instruction per second. They used rotating magnetic drums for internal storage and punched cards for external storage. Printing or running a program had to be coordinated manually. They were used for very limited scientific and engineering work. The common language used was machine and assembly languages. Examples of first generation computers to be used were: 1, universal automatic computers, first commercial computer delivered to business clients. 2, electronic numeric integrator and a computer developed by the Army to compute World War II ballistic firing tables. Second generation, that is transistor technology. A transistor versatile 3-lead semiconductor device whose applications include electronic switching and modulation, existed between 1957 and 1962. They used translators to store and process information. The translators were much stable and reliable than the vacuum tubes. They generated less heat and consumed less power. The translators were individually made and wired with two printed circuit boards. The magnetic core was used for primary storage technology. This was composed of small DAF size, which could be polarized in two or more directions to represent a bit of data. They still relied on a punched card for input and print out for outputs. Third generation, integrated circuit technology. Integrated circuit technology is a semiconductor crystal containing the electronic components for digital gates and storage elements. They came into existence in 1960s and existed between 1964 and 1979. They used integrated circuit for storage and process information. The computer memory expanded to 2 megabytes of ROM access memory. The processing speed was 5 million instructions per. The processing speed was 5 million instructions per second. The size decreased drastically. They drew less heat and they generated less power. This computer technology introduced software that could be used by people within extensive technical training, making it possible for computers to enlarge their role in business. The examples of third generation computer was IALIC 4, which was designed in the late 1960s at the University of Illinois, which had 64 separate CPUs, all supervised by a common control unit and all capable of operating simultaneously. Fourth generation, that is very large integrated circuit. These are integrated circuits combining thousands of translators-based circuits into a single chip. They are computers existing from 1980 to date. The computer of today use very large integrated circuits to store and process information. The integrated circuits are packed within 1,000 and even millions translators. Computers have a high storage capacity of 2 GB. The speed of computer is over 20 million instructions per second. They are very cheap compared to the first, second, and third generation computers. They are very small in size and faster at processing. They are advanced inputs and outputs. They are reliable and have higher processor power. In 1981, IBM introduced its first computer for the home use, and in 1984, Apple introduced the Macintosh. The fourth generation also saw the development of GUI, the mouse, and the handheld services. They are future computers that will use a variety of super chips with billions of circuits and using more of artificial intelligence. Though there are some applications such as voice recognition sensors that are being used today, the use of parallel processing and a superconductor is helping to make artificial intelligence a reality. Two major innovators are in experimental stages: DNA computers and optical computers. DNA computers take advantage of the fact that information can be written into individual DNA modules. They can handle parallel processing and are potentially twice as to the first supercomputers. Computer types. Computers used in business today are mainframe computers, mid-range computers, microcomputers, and supercomputers. Other computers classifications. Computers may be classified into according to sizes: mainframe, min and microframe, analog, hybrid, digital, special, and general. Processor power, we have high-end, mid-range, and a basic processor. Supercomputers is a computer with high-level computation capacity compared to a general-purpose computer. Performance of a supercomputer is measured in floating point operations per second instead of a million instructions per second. The fastest, most powerful, and most expensive computer system, designed specifically for a higher speed numeric computation needed in very complex applications such as weather forecasting and so on. Mainframe computer is a high-performance computer used for large-scale computing purposes that require greater availability and security than small-scale machine computer. The large, faster, and powerful computers often filling an entire room with very large storage capacities, primarily used by large organizations for critical operations applications, bulk data processing, support more network users and peripheral services. Mainframe computers can also be categorized into 1. Enterprise system, supervisor, super servers, translation process, and also supercomputer, and so on. Mid-range computer system categorized into network system, microcomputers, web servers, multi-users system, etc. Large and more powerful than Microsoft, but are similar and less powerful than mainframe. Categories of microcomputers will have handheld PC, notebook computers, desktop computers, workstation computers, network servers. Basic computer system concept. A computer is a system of hardware devised, organized. A computer is a system hardware devices organized according to the following system functions. 1. Input devices, stock technologies. 2. Processor. 3. Main memory and secondary storage. 4. Output devices, stock technologies. 5. The communication devices. Flow of information through hardware. Information is inputted in a hardware from the onset. It is put on the input. It's inputted through device, and it goes through the central processing unit. And from there, it goes through the main storage, and then it comes out as an information or an output through output device. An input device technology is used to enter data and instructions into the CPU. Input devices include the keyboard, the microphone, barcode reader, the touch screens, light pens, electronic mice, optic scanners, digital cameras and webcams, biometrics, finger scanners, voice recognition, and other peripheral hardware components that convert data into electronic machines readable form. Output device technologies continues. These are devices used to send data out of the system or communicate data processing results in a variety of forms. Video displays and the printed documents have been and are still the most common form of output from computer systems. Output systems include video display units, that's monitors, speakers, printers, audio response units, and other peripheral hardware components specialized in this function. The central processing unit, that is CPU. The CPU has referred to as the processor the CPU also referred to as the processor or microprocessor. It is the brain of a computer and therefore the most important part of the computer system. Carries out all the processing in the computer. Processor speed describes the maximum number of calculations per second the processor can perform and is given in megahertz and so on. Generally, the larger the number, the faster and the more powerful the processor. Inside the CPU, it has the arithmetic logic unit, which performs the arithmetic and logic functions required in computer processing. The arithmetic logic unit contains the circuitry that performs data manipulations. This unit performs all mathematical and logical functions. Mathematical functions include multiplications, division, subtractions, addition, and advanced mathematics such as logarithm, and so on. The control unit, that is CU, coordinates all computer hardware. The CU interprets computer programs, instructions, and transmits directions to the other components of the computer system. The CU performs the tasks of fetching from memory the instructions to be executed, decoding it by determining what is to be done, managing stored program execution, and then storing results. Registers. This CPU also contains circuitry for devices such as registers and cache memory. A register is a high-speed temporary storage of data and instructions. The registers are special-purpose temporary storage locations. They hold data needed quickly or frequently prior to execution and stores information about the status of CPU and the currently executing programs. Communication devices. Devices are capable of transmitting an analog or digital signal over the phone and the communication wire or wireless. Computers use communication devices such as modem. However, most computers today have Bluetooth devices, modem, network card, Wi-Fi devices, and so on. Main memory. The memory is the physical internal medium that holds data. Main memory is as vital as the processor chip to a computer system because it stores data and program instructions temporarily during execution. The two types are RAM and ROM. RAM in a microcomputer is volatile, which means that the contents of the memory are erased when the computer power is switched off. ROM is non-volatile memory, which means that its contents do not disappear when the computer power is switched off. Secondary memory. Secondary memory is where programs and data are kept on a long-term or permanent basis, therefore cost-effective. Common secondary storage services devices are the hard disks, memory sticks, and floppy disks. Some of the characteristics of secondary memory include the hard disks has enormous storage capacity compared to main memory. Computer specifications. We have the processor, hard drive disk, universal series bus, firewire, video or graphic cards, DVD or CD drives, monitor size and shape. We have warranties, backup systems, and printers. Members, thank you very much for listening.